Hello, welcome back to our eFarm Django tutorial series. I'm Peter Evans if you're new here. And so today we're taking a deep dive into two vital models in our project. And if you've been following along, you've already seen these two names, the flock source over here and the flock breed models. And now you might be wondering why we are revisiting these models. Well, the answer is simple. I've got some significant enhancements to share, and I promise you this is worth your time. And as I have always envisioned for this project, we are all about making eFarm the best it can be. And that means continuously improving and refining our code. And today's enhancements are the testament to this commitment. And so without wasting much more time, let's jump straight into our PyCharm editor. So over here, we have our flock source open and ready for us to explore. So the new enhancements in this model is just the aspect of validations that is applied on our clean method over here. So we have this flock source validator with the method validate source that shall be performing validations based off the name that is applied for our name field over here. So the same thing applies to the flock breed. You can see we have the clean method overridden over here, and we are calling this method validate breed name. So just jumping over straight to our validators.py. So here is our class flock source validator as well as also the flock breed validator. So the validate source method inside this flock source validator is just a static method that accepts a single parameter, that is the name parameter. So we are performing these two validation checks based off the name that is applied. First up, the name must be a valid flock source choices. So choices over here, you can see we have this farm, the Ken chick, the Cuckoo chick, the Uzima chicken, and also the Keeples farm. So that is what we are doing over here in this first if block. And then the second if block, we are checking if the flock source that is supposed to be saved or maybe updated is something that is actually already into the database. So we are preventing duplicate flock sources. The same thing applies to the flock breed validator, where we also ensure that the name must be from the flock breed type choices, or maybe if the flock breed had already been saved, then we ensure that there's no duplicate that is saved again. And that's it for the new enhancements that we've added for our models. So I'll quickly head over to our permissions over here, since this is the new stuff that we've added. So over here, let me just collapse this. We have 6 new permissions. That is the can add flock source, the can delete flock source, can view flock source, can add flock breed, the can delete flock breed, as well as also the can view flock breeds. So I'll quickly go over through this very first one, the can add flock source. So this shall be a custom permission class that allows the farm owners as well as also the farm managers to add flock choices. So this can add flock source inherits from the base permission class that is imported from the REST framework's base permission module. So we shall be applying this permission class to our creation action in our view to ensure that it's only the farm owners and the farm managers who can actually add new flock sources in our farm. So the operational principle is that this method over here, the has permission, is gotten from the base permission class from the REST framework permissions module, where we override it to ensure that the request user that is actually associated with the request object is actually authenticated, as well as also marked as either a farm owner or a farm manager. And if that's the case, then the has permission shall actually grant the go ahead for the further processing of that request. If not, where the first occasion is where maybe the request user that is associated with that request object is still maybe flagged as an anonymous user, then we shall raise the authentication failed of the message, the authentication credentials were not provided, or maybe if the request user that is associated with that request object is actually not having the sufficient rights, then we shall raise a permission denied error of the message only farm owners and farm managers have the permission to perform this action. And so all these other permissions also operate on the same principle, just like even this one for the deletion of a flock source. We also just allow the farm owners and the farm managers to perform that. And so that's it for the permissions. And in our serializers, there's nothing really new. All is just like as it was in the previous tutorial. And then now we shall head over to the views. So over here in our views, we've actually customized whatever we had from our previous tutorial. And in the previous tutorial, our model view set was quite simple. We were only just specifying the query set as well as also the serializer class. And so today we've actually enhanced it and introduced some functionalities such as the filtration, the ordering, and the things like the permission checks and many more. And so starting off with our Fluxus viewset, we are actually activating the filtering as well as also the ordering aspect of our Fluxuses based off the name. So the Django filter backend over here is imported from our package, the Django filters, as well as also the ordering filter class over here is important from the REST framework filters module. And so then we also override the permissions, the default get permissions method in our model viewset class, where we ensure that all those permissions that I've just briefly talked about just a couple of seconds ago are actually applied here, where we ensure that if the create action where they start post request, then we apply the can add Fluxus, where we only allow the farm manager and the farm owner to add new Fluxuses. Well, if the action is to be a deletion, and then now we also apply the can delete Fluxus, where it's also the farm owner and the farm manager who can do so. Then if it's something to do with, let's say, the viewing or maybe the retrieving of the Fluxus, then all the farm staff can do so. And I think for that I didn't really explain it, but I can just revisit it a little bit. Yeah, so you can see over here that this one has like plethora of people who are actually specified here, starting with the farm owner, the farm worker, the farm manager, as well as also the assistant farm manager. And so back to our views. Now, in our view over here, we are actually restricting the updating of the Fluxus. So the reason why I'm doing this is to ensure consistency in data, because once we actually have a Fluxus and then let's say we start adding the flux, then there'll be a reference or rather a foreign key to this Fluxus, and so we just want consistency. But anyway, if there is a need to actually implement the updating aspect of our Fluxuses, then as well I will also consider that. But for now, this can really suffice, where if an update is attempted to a Fluxus that is already saved in our database, then we shall raise a HTTP status of 405, that is the method not allowed error. And then now we also override the list method of our model viewset class over here to ensure that since we have actually introduced the aspect of filtering and ordering, we can also do that if the query parameters actually have specifications of that kind, where in the first case we ensure that if the query set does not exist because the query parameters does not actually filter anything from our database, we shall return the HTTP response of no Fluxuses found matching the provided filters, and of the status 44 not found. Or maybe if we just do not have any Fluxuses that are already added in our farm, so we shall return an HTTP status of the 200 OK. So these are two valid scenarios where we can have empty query sets. I hope you understand that. And then in cases where we have multiple Fluxus objects from our database, we shall specify main is equal to true for this method for it to know that we are having multiple objects to be serialized. And then for that case, we shall be serializing all of that data and then returning a HTTP of the status 200 OK. And then we also have the flockbreed viewset that is almost 100% similar to whatever I've actually just explained for the Fluxus viewset over here. So we are also just activating the filtering and also the ordering functionality for our flock breeds. And then we also override over here the permissions to ensure that whatever we actually specified in our permissions, like for the case of the creation of a new flock breed, we shall only allow the farm owner as well as also the farm manager, those who are specified in this, they can add flock breed permissions. So over here, we also restrict the update to ensure the consistency of data in our database. But then in future, we can also consider refactoring this logic over here where we are restricting the update. But for now, this would suffice. And then we're also doing the same thing as we've done for the list method to ensure that if the request query parameters has some parameters that are associated with it that does not return anything, then we shall do this. And then if maybe we just do not have any flock breed in our database, then we shall return this and then perform the same thing if maybe we had multiple flock breed objects in our database. And so that's it for the enhancements that we have in our view sets and the whole code for this tutorial in general. So as a rule of thumb, we shall go ahead and run the tests. And then from the previous tutorial, by the way, we had not actually started testing the poultry models, and I mean just everything that is inside the poultry app. So for this tutorial, we've actually now introduced this new folder, the poultry, inside the base test folder. So inside the poultry, we have a folder named tests, and inside the tests, now we have the test views over here. So I hope maybe if you went through the dairy app, you understand the concept of having this conf test over here. We are using PyTest package for performing the tests that we have in our whole project, and the PyTest actually regards this file named conftest.py to be containing fixtures that we have. Like you can see in this case, we have this method, the setup users, that shall be actually yielding the tokens and also the IDs, or maybe the users that we shall be using to send the request for our views. Like in this case, we have the regular user token, we have the farm owner, the farm manager. Like here we have the farm manager token. So these are the stuff that we shall be using to perform the HTTP request as we are testing our views. So straight into our test views over here. So I'll just quickly go ahead and maybe explain just two tests in the interest of time. So starting over with the test flock source view set over here, we are actually now sending a post request to this URL. So it will be localhost/poultry/flock sources. I hope you understand right now whatever this reverse function does. What it does is that it goes ahead and then resolves the URL. And then the syntax that I'm using over here, maybe somebody might have not known up to now, but what is happening over here is that if you see, I having the poultry, I mean this string poultry, then full colon, then the flock sources list. The poultry over here is the app name that we've specified. Let me show you. In our poultry URLs over here, you can see we have the app name poultry. So this shall actually allow us to construct these URLs without confusion. Like let's say if maybe our poultry app had, let's say, an index, a view, and also our dairy app also maybe has index view. You see, there could be confusions, and this is a way that Django actually provides for us to avoid such confusions. So just like I have said, this shall resolve to something like the localhost/poultry/flock sources, and then also the request payload right now over here is the flock source data. So the flock source data over here is just this dictionary that I've actually created over here, where the flock source data shall now require this as a field name, and as well as also a valid flock source choices from the choices that we have. And then now for the authorization aspect of whatever we have, we shall be sending the token of the farm owner and then testing if actually the farm owner can create, where the HTTP status that shall be returned will be the 201 created. And then we also check that the flock source object actually that is created corresponds to whatever we have. That is a flock source data dictionary over here. And then in similar light, we also now actually test that the update for the flock source objects are actually denied, where we actually first of all create a flock source object in our farm, and then we try sending a put request in order to update that flock source data, and then we assert that the status that is returned is the 45 method not allowed. And so that's it for the flock source test. Same thing just applies to our flock breed view set, just like you've seen, they are quite similar. And so with that, I do believe that that's enough for this tutorial. We shall go ahead and then now just run the test as usual. So in this case, I will just run all the tests that we have in the whole project. So PyTest. Sorry, there is a problem over here. We have the time zone not defined. So I'll just quickly go ahead and check it out. So we have time zone not defined over here. Let me just import it from the date time, the Django utils. Okay, let me use that. Then try it over again, PyTest. Well, now everything is running. So we have 312 tests for whatever we've actually done, both the dairy and also the poultry. So I'll just quickly go ahead and fast forward this, and then I'll come back after the test I've actually ran all of them. Alright, so in 350 seconds, all of our 312 tests have actually passed, marking the end of this tutorial. So if you have a question, don't hesitate to ask that in the comment section below, and I'll see you in the next one. Bye bye.